My name is Emma Shedler, and I am a second-year student in Biology 182 at Arizona State University. Today I will be dissecting for you a study that my team and I performed in order to better understand species activity in the Serengeti. As a brief introduction to our study, the basis of our study was derived from the want to know more about how species interact with each other as well as their ever-changing environments. And because our point of study is in the Serengeti, we of course use species that are endemic to the area, such as lions and their common prey species, in order to explore such interactions. In order to better understand just how natural and behavioral elements impact the lives of some of the Serengeti's most iconic species, we did ask these big three questions, which you can see over here on the left-hand side of the screen, which are: do predators influence vegetation? Are predator and prey activity periods varied? And how does weather affect species activity? In order to narrow down this data that we would need to start answering these questions, we hypothesized and essentially predicted that a lack of predators would deplete vegetation due to an abundance of herbivorous prey. Prey will have alternating activity patterns to predators in order to avoid to be preyed on, and species will be more active during rainy or overcast weather as there will be less heat and likely more vegetation during these periods. Before we could even begin data collection, we had to preface by gathering a couple different tools that we used during the entire collection process. Probably the most important out of these was the JMP or JUMP software, which essentially was a software program that allowed us to take data from an Excel sheet, plug it in to this software, and get this gorgeous comprehensive graph out of it, which we actually used to select our significant data points. In addition to this, we also needed a computer with internet access, Excel, and of course our mega data sheet provided by Snapshot Serengeti, from which we withdrew all of our data points. This graph here will let us explore how predators influence vegetation, which was our first question. And our prediction for this graph was that a lack of predators would deplete vegetation due to an abundance of herbivorous prey to come and eat all that vegetation. So given the utilized data points, the JMP software actually allowed us to numerically interpret these graphs. So results from the graph of lion risk versus vegetation showed us that from areas of 3,000 to 6,000 ratings of greenness, and we graphed both wet and dry levels, that male and female lion risk followed actually similar trends as these dryness and wetness periods, with lion risk during dry seasons experiencing limited significant peaks greater than 50% average risk. These second two graphs shown here will allow us to explore our second big question, which was, are predator and prey activity periods varied? And for this question, we predicted that if Serengeti predators, in this instance male and female lions, are diurnal, which means active during the day, prey species will be most active at night because there will be less chance of predation or being preyed upon. Of course, here in the images, the left graph is going to display our lion activity across a period of 12 a.m. to 12 p.m. And our second graph here is going to show the numerous prey species that are common of lions versus this same time period of 12 a.m. to 12 p.m. You can see from these graphs of the common prey species and lions versus a 24-hour time period show that on average, lions and their prey species are most active around the same daylight hours of 8 a.m. to 4 p.m. These last two graphs here will allow us to explore our third and final question, which was, how does weather affect species activity? For this question, we hypothesized that if the weather is raining or overcast, there will be more animal activity because there will be less heat in the environment, and as a result, there will be more vegetation as well. And within these graphs here on the left, this is a graph of lion risk to show presence of lions versus the dry season months, which are May to August respectively. And here on the right, we also have lion risk graphed against the rainy season months of November to April, respectively. So results from these graphs of lion risk versus season evidenced actually similar results as our graph of lion risk versus greenness, which was our very first graph that we showed, with a noticeable increase in both male and female lion population activity during the dry season months, which were May to August. Interestingly, an analysis of results concludes quite a striking array of behavioral patterns from species of the Serengeti that are affected by their ever-changing environment. Results from our first graph of lion risk versus vegetation concludes that there appears to be no significant change in vegetation despite lion risk levels. This data suggests that even with top predators, which are lions, present, the vegetation consumption by herbivores remains relatively constant, which actually disproves our original hypothesis that the presence of predators will cause vegetation to increase. Interestingly, in addition to this, the graphs of lion and lion prey species activity levels versus time of day disproves the hypothesis again that prey will sustain alternating activity levels to avoid predation. However, this data actually suggests that lions adopt a similar activity pattern that their prey species do, perhaps to gain the greatest advantage of predation as prey populations are more abundant during these times. And lastly, similarly to the results of our lion risk to vegetation data, the consensus of the graph between lion risk levels and the Serengeti's wet and dry seasons appears to remain relatively constant as well. However, it can be noted that lion activity does experience a slight increase during the dry season. This actually might be due to greater hunting grounds, as they are less likely to experience flooding. This also disproves our last hypothesis that greater rainfall will result in greater species activity. Although this study only focused on lions, which are a predator species. Future studies that observe prey species activity during wet and dry seasons may actually yield differing results, which actually leads us to other future relevant follow-up questions